In order to start talking about acceleration, we need to at least come up with a base definition. So just the idea of acceleration, I think most people understand an object speeds up, slows down, you're accelerating, something like that. So the technical definition we're going to start off with is that acceleration is a change in an object's velocity over a given amount of time. So I think most people innately probably come into a physics course understanding the basic idea that if you're accelerating, an object is speeding up or something like that. Now, I always ask, what are the ways in which you guys believe an object can accelerate? And I would say 90% of the time, the classes always give me two answers. So they usually tell me that an object is accelerating if it's speeding up or it's slowing down. And these are both correct answers. However, this is not the entirety of the answer. So this is 2/3 correct. If you speed up, you are certainly accelerating. If you are slowing down, you are certainly accelerating. But we have to remember that acceleration is a change in an object's velocity over a given amount of time, not just a change in its speed. And velocity is a vector, so speeding up or slowing down will certainly change the value of my velocity. But the one thing that students tend to forget is that the change in direction an object experiences is also going to change its velocity. The way I kind of try and get this across to everyone is to imagine you're in the passenger seat of a car, maybe your eyes are closed, you're trying to sleep. If all of a sudden the driver slams on the gas pedal and that car speeds up suddenly, you will feel that acceleration. You'll feel the seat pushing forward. Even with your eyes closed, you know that that object is speeding up. You know that you're accelerating. Similarly, if you're sitting in the passenger seat and your eyes are closed and you're going about 60 miles an hour and the driver slams on the brakes, you will also feel that as well. You'll feel yourself get thrown forward. The seatbelt's going to try and pull you back. You will feel the result of that acceleration. Well, likewise, if you're going at about 60 miles an hour down the highway and the driver suddenly starts turning the wheel from side to side, you're not speeding up and you're not slowing down, but you certainly feel that change in direction. So that's why we have to realize that all three of those are methods of accelerating. The third one there is one that students typically don't realize or often forget about. So speeding up, slowing down, or changing direction are all ways in which acceleration can occur. Now, the most confusing thing about acceleration and velocity is the direction of each in a given scenario and what impact that has on the object's motion. So we are going to take a look at these four scenarios. So we have a situation where someone is pushing a block to the right up top while that block is already moving to the right. So the block is sliding to the right and someone's pushing it in the same direction that it's going. In the second case, the block is sliding to the left, but the person is trying to push it to the right. So maybe they're trying to slow that thing down. In the third scenario, we have a block that's sliding to the right, but being pushed to the left. Again, that person's trying to slow that block down. And in the last case, the block is sliding to the left, the person's pushing to the left. They're trying to speed that thing up, let's say. So the velocity and the direction of the velocity is the easy one. The direction of the velocity is quite simply the direction that the object is moving in. So in that first case, ignore the person pushing. Because that block is moving to the right, we simply say it has a rightward velocity. In the second case, again, ignore the person who's pushing. That block is moving to the left, so we say it has a leftward velocity. You can try the third and fourth ones for yourself. Take a second and try and figure out what direction you believe the block's velocity is in the third and fourth case. So in the third case, it's to the right simply because the block is moving to the right, and it's to the left in the last case simply because the block is moving to the left. The acceleration is not directed in the direction the object is moving. It is directed in the direction that the object is being pushed or pulled. So because the person in that first example, regardless of the direction that the object is moving, because it's trying to push that object to the right, that means that the acceleration in the first case is to the right. In the second case, even though the block is trying to move to the left, the person is trying to push it to the right, so we say that it has a rightward acceleration. So regardless of the direction of the block, because the first two examples have somebody trying to push the block to the right, we say that the acceleration of those scenarios is acting to the right. Likewise, regardless of the direction the object is moving in for the third and fourth cases, in both of those scenarios, the person is trying to push that block to the left. So in both of those cases, we say it has a leftward acceleration. So why am I going over all of this? Because we also want to try and figure out whether these objects are speeding up or slowing down. So if you just think about your own life experiences, if you are pushing an object in the same direction it's already going, some students walking down the hall in front of you, you push them from behind, you push them in the same direction that they're going, that object is going to speed up. If, however, an object in the second case is trying to go to the left, but you are trying to push it to the right, hopefully you realize that that's going to cause that object to slow down. Similarly, for the third case, if an object is trying to slide to the right, but you are trying to push it to the left, it's going to slow down. And in the bottom, if you are trying to push the object to the right and it's already going to the right, that object is going to speed up, just like it did in the first case. So the big takeaway from this entire little scenario here is that whenever the velocity and the acceleration act in the same direction, doesn't matter if it's both to the right, both to the left, anytime the velocity and the acceleration's directions line up, that will result in the object speeding up. And anytime the velocity and the acceleration act in opposite directions, that object will slow down. Now, the velocity is always pointed in the direction the object is moving. The acceleration points in the direction of whatever is pushing or pulling that object. So if you know an object is moving to the right, you immediately know that its velocity is directed to the right. Then the direction of the acceleration, while not always in the same direction you're moving, will determine whether or not that object is speeding up or slowing down. So we can look at, let's see here. We can look at a conceptual example just to help you out. So in this scenario, let's assume you're sitting in your car at rest at a stop sign. You've come to a stop, there's no cars coming, so you decide you are now going to move forward. Well, you were at rest at the stop sign, so you now have to hit the gas pedal and speed up as you move forward. Then we'll assume a little bit further down the road, you're approaching another stop sign, so then you have to hit the brake and slow down. So if we wanted to put this into words in terms of the direction of the velocity and the direction of the acceleration, for the first part where we say it's speeding up, again, I'm going to use the direction on the screen and assume it's going to the right. While you're moving away from the stop sign and you're picking up speed, you're moving to the right, so we say you have a rightward velocity. Because you are speeding up, you must also have a rightward acceleration. The engine is pushing your car to the right in the same direction you're traveling in. Then a little bit later, you can try this one. If your car is slowing down, it's still moving to the right as it approaches the stop sign, but it's starting to slow down. So if you think about that for a moment, the fact that you're traveling to the right means you have a rightward velocity, but the fact that you're slowing down means that you are now actually accelerating to the left. So the friction between the tires and the roadway, or the friction of the engine on your wheel axles, however you want to phrase that, something is trying to push your car backwards, which is actually what's slowing it down. So we say in the second case, you had a rightward velocity and a leftward acceleration. And because those were in opposite directions, that's what's causing this car to slow down.